Good morning, learners. Today we are going to study the detailed solutions of paper 41, number 9, May June 2020. So this is our problem number 9. The diagram shows a sector of a circle with center at O and radius 8 centimeters, OA 8, OB 8, and a sector angle of 165 degrees. Question letter A. Calculate the total perimeter of the sector. So we need this one. So let us call that one as S for subtended arc. So the formula for the subtended arc and the formula for area of a sector is this. For subtended arc, our length of the arc is r theta. What is this theta? This theta is the angle, the central angle in radians. So that 165 degrees must be converted into radians. Let us solve for S. We have the radius 8 centimeters, but we don't have yet the angle in radians. So let us compute the theta. For the theta, we have 165 degrees. This is ratio and proportion. Is part of the whole 360 degrees is equal to, what is this 165 degrees in radians? And the whole circle, which is 360 degrees, is the circumference of our circle, in which the formula is 2 pi r. This is the circumference. This one is the circumference also in degrees. So to compute for x, we just cross multiply. So we have here x, which is actually our theta in radians, is equal to, so we have 165 times 2 times pi times the radius of 8 cm. Then we divide this by 360 degrees. And we will find out that our theta, which is x there, is equal to 165 times 2 times 3.142 times 8 equals, divided by 360 degrees, and it will give us 2.88. The unit now is radians. So we have radians. And then we can find now the S, the subtended arc. So S now here is equal to the radius, which is 8 there in cm, times the central angle in radians, which is 2.88, and our S class is equal to 23.04 centimeters. Now, can we find now the perimeter of our sector? Yes, we will add the 8 here, plus the 8 there, plus the S. So we have our perimeter here. Perimeter is equal to 8, plus another 8, plus the S, which is 23.04. And our perimeter here is equal to 39.04 centimeters. Letter B. The surface area of a sphere, this is our sphere, is the same or equal to the area of our sector. calculate the radius of our sphere. So let us first compute the area of our sector, and the formula for the area of our sector is this. Area of sector is equal to 1/2 the radius squared times the central angle in radians. Now, the central angle is already solved. We have solved that one already. And our theta, this one, is equal to 2.88 radians. Okay. The area of a sphere is 4 times the area of our circle, which is 4 pi r squared. Area of a circle times 4 is area of the sphere. So let's compute first for the area of our sector. So for the area of our sector, this one is sector. So we have 1/2 times the radius of our sector is 8 squared times the central angle in radians is 2.88. So our area of the sector here is 8 times 8 is 64 times 2.88 equals divided by 2, and our area of the sector is 92.16 cm squared. Now we will equate this area of our sector to the area of the sphere, which is 4 pi r squared. So we have here this 4 pi r squared is equal to the area of the sector, which is 92.16. And then to get the r, we have r squared now is equal to the 92.16, and then we divide it by 4 pi. 4 times 3.142. Okay, that's it. And then after multiplying this one by 4, this 3.142, we divide this 92.16 by this one, and our r squared will be 7.33. And then we take the square root of that one, so r is equal to square root of 7.33, and our r is 2.71 centimeters. That is the radius of our sphere. Letter C, we have a cone. This is our cone, which is made from this sector by joining OA and OB. So our sector like that, and this portion here, class, which is the subtended arc, which we have solved earlier, is 23.04. So this one forms this one. So the S becomes a circle, and to find the length of that one in formula, that is the formula for the circumference of our circle, which is 2 pi r. So here we need to find the radius by using that formula, and after that one we'll find the h. So we have the subtended arc, which is 23.04, and this one is now the circumference of the base of our cone. So this one, the circumference formula is 2 pi r. which is the subtended arc 23.04. To solve for this arc, so we'll just divide this by 2 pi, divide this also by 2 pi, and our radius here is equal to 23.04 over 6.284. Okay, we multiply 2 times 3.142 and we have 6.284. And dividing this one, we have 3.67 centimeters. That is the radius of the base of our cone. CII, we have calculated the volume of the cone. So we have our cone here, and we have already solved the radius of the cone, which is 3.67 centimeters. Now in our formula here, we don't have yet the h, the height of the cone. So we are going to solve that one by Pythagorean theorem, because this is a right triangle. The slant height of our cone is 8 centimeters, is the hypotenuse of our triangle here. So we have here 8 squared, which is the hypotenuse of the triangle, is equal to h squared plus the radius squared. And we have 8 times 8 here is 64, is equal to h squared plus this 3.67 squared. We have h squared, so we have 64 minus v squared. That one, 3.67 times 3.67 will give us 15.4689. And then h, now we take the square root of 64 minus 13.4689 is 50.5311, and taking the square root of that one, h now, or the height of our cone is 7.1 centimeters. After finding the h, we can solve now for the volume. So the volume of our cone is 1/3 times pi times the radius, which is 8 squared, times the height now, which is 7.1 centimeter. For the volume, we have here 8 times 8, 64, times 7.1 times 3.142 equals, and then divided by 3, that will give you a volume of 100 cm